Hey everybody, this is Matt with mathsmath.com. Thanks for joining us here today as we check out proportions. What are they? We'll be answering that today. Well, today we're in the Common Core Standard of Ratios and Proportions, and we're going to be analyzing and using proportions to solve real-world problems. Let's get to it. Well, our guiding question is, how can we determine if something is fair? By using proportions, we will be able to tell if something is fair or not, whether it's right or whether it's just, hey, I'm getting cheated out of a deal here. All right, we'll be looking at that question today. So here's an example of a proportion. Really what it is just two fractions set up and they're equal to each other. So 2/3 equals 4/6. That's pretty generic, right? You just take the 2 here, multiply by 2, you get the 4. Take the 3, multiply by the 2, and you get 6. So this is a proportion because they're two fractions equaling each other. And that's it. Pretty simple, huh? All right, well, let's talk about it now. Let's talk about if something is fair. Well, if you think about whether something's fair, hey, your classmate gets $5 and you don't. You're thinking, hey, this is not fair. Wait, he got $5 and I didn't? That's not fair. Something ain't right about that. Now, it might turn around in your favor and be like, hey, that person took $5 from that person. Hey, I still got my $5. But was it fair? No, it still wasn't. All right, well, look at these examples. Are you doing the same on each day, or are they fair or not? So let's talk about it this way. Batteries. All right, first battery on the first day, you get 2 boxes for $5. Okay. On the next day, when you go back, you realize, hey, I need to buy some more batteries. It's 3 boxes for $7.50. Are those the same price? Are those fair? Well, if you think about it, 2 boxes for $5. That's 1 box is $2.50, and here 3 boxes is $7.50. So again, break it down. 1 box is $2.50 also. So those are equivalent. Now, if you don't know what the word equivalent means, it means the same or equal. Okay, so yeah, man, there it is. They're the same. What about the first day here? You're driving 1 mile and you're getting 50 miles, or 1 hour and you get 50 miles, and here you get 1¼ hours and you're driving 75 miles. Are those the same? Did you have the same rate? Okay, think about it here. 1 hour's 50 miles, 1¼ 75. Now, those really aren't equivalent. If you think about it, 1¼ well, what's half of 50? It's 25, and that would be have to be an hour and a half. So you really would be 75 miles in an hour and a half, whereas here it's 75 miles in an hour and a quarter. Not equivalent. Those aren't the same on each of those days. What about this one? You're racing these ladies here, and you're burning 300 calories in 4 miles. Well, in 3 miles, you're burning 225 calories. Are those the same? Well, if you think about it, you got to break it down into how many calories are you burning per mile. That might help you out there. Okay, they are equivalent. If you break it down into 1 mile here and 1 mile there, you see that the calories are the same you're burning on each day. Why don't you do this one? All right, first day you get 5 songs for $2.25, and the next day you get 4 songs for $2. Are those equivalent? All right, if you think about it, 4 songs for $2, that's 50 cents a song, right? So if you add 1 more and you get 5 cents, it'd be $2.50. So this is the better deal here, 5 songs for $2.25 as opposed to 4 songs for $2. All right? So let's set up a proportion with these examples. Let's talk about it this way. I pay $184 for 2 concert tickets, and you pay $266 for 3. Did we pay the same rate? Did one of us get a better deal? All right, well, if I paid $184 for 2 and you paid $266 for 3, we'll write a proportion that looks like this. $184 for 2, $266 for 3. I can also write it like this, 184 to 2 and 266 for 3. I can't flip-flop other numbers and say 184 per 3 and 266 for 2. All right, that would totally change the math problem in general. But you can write them either way, okay? And you can put the 2 on top and the 3 on top and then dollars on bottom. Same thing here. You can flip those numbers around upside down. But you got to keep them stacked up, either together here or together there. Does that make sense? Dollars here, and then the me, and this is you, and then dollars here, this is me, and this is you. All right, so let's figure out, how do we do this? Well, the quick and easy way is to cross multiply, and that's how you tell whether they're the same or not. So if you go back to the problem here, let's cross multiply. It would be 184 times 3 and 2 times 266. Well, once you cross multiply, and if those numbers are the same, then it's a proportion. You're paying the same rate. Whereas you notice, if you take 184 times 3 and get 552, 2 for 266 and get 532, these are totally different rates. One of us got a better deal. Okay? Or the other way to do it is just to simplify. Okay? You simplify the fractions there. 184 divided by 2 is $92 per ticket, and 266 divided by 2 is $88.67 per ticket. So notice that per ticket, my friend got a better deal, 88 bucks as opposed to $92, okay? So those are two different ways to do that, to solve proportions into right proportions. And we realize that they're not equal or they're not fair because we compare the rates and they're totally different. Now why don't you look at this one, see if you can set up the proportion. I get 75 points for answering 15 questions correctly, and you get 70 points for answering 14 questions correctly. Were our tests graded fairly? Were they the same? Were each question weighted the same? Alright, if you write a proportion, it's going to be 75 over 15 and 70 over 14. Cross multiply and see what you get. Here it is. Well, they are equal, because when you cross multiply, the products are the same, or when you simplify, you get the same rate. Each question was worth the same amount of points. Okay? So, let's get a formal definition here. Proportional ratios. That's really all it is. It's proportions. This is your word, your big word for today. It's two ratios that are equivalent when simplified. Or two fractions. Remember, ratios are pretty much the same as fractions. They're equivalent, meaning they're equal, when simplified. You break them down to the lowest groups, and here you get it. So, for example, 2/3 equals 4/6, because when you break down 4/6, take out a 2, you get 2/3. Or this one, 7/49 is the same as 1 over 7. Cross multiply, 7 times 7 is 49, 49 times 1 is 49. Simplify 7/49 and you get 1 over 7. The same thing here. But not these guys. If you cross multiply, 3 times 4 is 12 and 5 times 2 is 10. They don't equal each other. Same thing with this. 7 times 7 is 49, 48 times 1 is 48. So one of those is a better rate. They're not fair. And that's really all proportion is. Two fractions with an equal sign in the middle. Right? Something is said to be proportional when the quantities or the totals form a proportion. That's the general statement there. It's proportional. Well, let's tell whether these ratios are proportional. If they're not, make them proportional by changing one of the numbers, okay? So let's try that. 1/5 compared to 5/15. Are they proportional? Can you put an equal sign through there? Alright, well if you cross multiply, 5 times 5, that's 25, and 15 times 1, that's 15. No, those aren't proportional. Alright, not proportional. Well, 1 times 5 is 5. What number would I put there to multiply by 5 to get 15? Well, if I wanted to change it, I'd put a 3 here and it'd be good to go, right? 1 times 5 is 5. 3 times 5 is 15. That's how you could change it. Alright, you could simplify it and see if they're the same. Whereas this one, you might want to cross multiply or simplify, right? 4 times 6 is 24. 24 times 1 is 24. These are a proportion. What about this guy? 15 over 2 and 20 over 5. Okay, if you cross multiply, 15 times 5 and 2 times 20, those are not the same. All right? I can make the second one a proportion if I said, hey, 2 times, if I multiply each of these by 2, 15 times 2 is 30, 2 times 2 is 4. You could do 30 over 4, and that would be good to go. And these guys. All right? What do you multiply 7 by to get 49? This is another trick that you can learn too, put in your tool belt. 7 times 7 is 49, 5 times 7 is 35. So these are the same, because if you think about simplifying 49 over 35, you would take out a 7, just like you would multiply 7 times 7 to get 49, 5 times 7 is 35. So there's really 3 crucial ways for you to be able to tell whether these are a proportion or not. All right. Why don't you work on these on your own? 28 points in 3 games, 112 points in 12 games. Is that the same rate? Are you doing the same per game? 32 notes in 4 measures and 12 notes in 2 measures. Are those the same? and you can type 105 words in 2 minutes, and your friend can type 210 words in 4 minutes. Are these rates proportional? Please tell me why. All right, if you're setting up the fractions right, you'll be able to tell these pretty quickly, whether by cross-multiplying, simplifying, or seeing how you can multiply to get to the other side. All right, 1 is yes, 2 is no, 3 is yes. Bam, that's it. How you doing? Are you able to answer this question? How can we determine if something is fair by looking at a proportion? I bet you are. All you're doing is looking at those fractions, simplifying or cross-multiplying, and bam, you're good to go. Well, that's it as we talked about proportions today. This is Matt with mathsmath.com. Check us out on Facebook at Solving Math Problems, or on Twitter at Maths Math, and enjoy math and playing fair.